Hello everyone, and welcome to this video tutorial on image classification using a convolutional neural network, CNN, in Python. In this tutorial, we'll use the popular deep learning framework TensorFlow and the Keras API to build a CNN for image classification. We'll walk through each line of code to understand what it does and why we've chosen specific parameter values for our image classification model. In the first few lines, we import the essential libraries. We bring in TensorFlow, a powerful deep learning framework. We also import Keras, an API integrated with TensorFlow that simplifies building neural networks. Finally, we import some specific layers from Keras, which we'll use to construct our CNN. We're loading the CIFAR10 dataset. It's a widely used dataset for image classification, consisting of 60,032 x 32 color images in 10 different classes. This code snippet loads both the training and testing data because it provides a good balance of complexity for our model. To ensure our data is ready for training, we need to pre-process it. Here, we're normalizing the pixel values of the images to a range between 0 and 1. This is a common pre-processing step that helps the neural network learn more effectively and ensures that differences in pixel intensity don't overly influence the training. Now we define our CNN model. It's structured using Keras sequential API. The model contains a series of layers: convolutional layers, max pooling layers, and fully connected, dense layers. We choose these values based on a balance between model complexity and practicality. The number of filters, filter size, and layer activations are chosen to capture a wide range of image features. And the number of output neurons in the last layer matches the number of classes in the CIFAR10 dataset. Here, we compile our model. We specify the optimizer as Atom, a widely used optimizer that adapts learning rates during training. The loss function is sparse underscore categorical underscore cross entropy, a good choice for multi-class classification tasks like CIFAR10. We also choose to monitor the training progress using accuracy as our evaluation metric, as it's a commonly used metric for classification tasks. Training the model is where the magic happens. We use the fit method to train our CNN on the training data for 3 epochs. The number of epochs in this case provides a good balance between training time and model performance. Additionally, we validate the model on the test data to ensure it generalizes well. Let's wait while it loads. Let's wait a few more seconds. There you have it. We have completed all 3 epoch stages. As you can see, the loss score drops as the training progresses. On the other hand, the accuracy continues to rise. At the end of 3 epochs, our loss score is at 0.92, while accuracy score is 67%, pretty decent. Finally, we evaluate the trained model using the test data. We calculate the test loss and test accuracy, which tells us how well the model performs on new, unseen images. The test accuracy is printed out for us to see and provides an indication of the model's classification performance. That's it. You've just seen how to build a CNN for image classification using TensorFlow and Keras. We've made choices for our model's parameters based on the characteristics of the dataset and the balance between complexity and efficiency. You can further customize this code for your specific image classification tasks or datasets. Thank you for watching, and I hope you found this tutorial helpful. If you have any questions or need assistance, feel free to leave a comment below.